done with solving the constraint optimization by using the Lagrange and Cantucker. All right. So now we have another method which is modified Hooke and Jeeves. So we have learned Hooke and Jeeves method before this. So this modified Hooke and Jeeves is used for constraint optimization. All right. So in Hooke and Jeeves previously, what we have done is what? Find the search by using the point most movement from left to the right, from up to down, and from in front to the back, right? So consider the successness of the function and decide where is our next move, right? So that one is for Hooke and Jeeves, as long as the objective function is reduced for minimization problem. All right. So now this modified Hooke and Jeeves will consider. So we are going to consider the constraints. Okay, instead of only focusing on the objective function, so we need to consider all constraints given for each iteration, for each exploration search, right? So we explore from the pattern point and then move to the another base and so on. So we have to consider all constraints. Okay, so now for this case, we have three constraints. So we need to make sure that all constraint is fulfilled. Then the objective function will be given such a high value if the constraints are not fulfilled. So what is the meaning by this? So for each iteration, for each testing point, we have to take a look at the constraints. Okay, if the constraint is fulfilled, if yes, we need to proceed with the calculation as usual practice in our Hooke and Jeeves method. But if not, then the objective function will be given such a high value of such that 10 to the power of 3, not 3, 30 actually, 10 to the power of 30. Okay, then we have to search again through the search again the objective function value compared to this high value to determine or to decide the successness or failure of the testing point there. Then the disadvantages of this method is it cannot move through the whole constraint, only at the first step. All right, so now let's take a look at the example here. So the idea here is same with the Hooke and Jeeves method, like we did previously, but only if the constraint is not fulfilled, then we substitute the high value of 10 to the power of 30 in the objective function. So how can we do this? All right, so let's take a look at this example here. All right, so now basically from Hooke and Jeeves method in our previous lesson, what should we start with? We have the function, right? And we have B1 as your starting point, okay, as your initial point. So we are going to start with our evaluation from B1, okay, and then the start length is given H1 as H2 equals to 1. All right, so we have to find what is our first step here, what we need to find. Revise back your Hooke and Jeeves method. Anyone? Yes, we have to find the value of the objective function by using B1 there. Right, so when FB1 equals to 43, then what is your FB1? One for one. All right, thank you. So you start with the exploration start from B1. All right, the next one, the movement process. What is your next evaluation point? We start from B1, 4, 3. So we move to the right. We have what? We have 5, 3. So 5, 3, F 5, 3 equals to? Come on, let's do this together. All right, thank you. So 180. So 180 consider as fill. Then move to the left. What is the point? So we have 3, 3, right? And then identify whether it is failure or success. So 3, 3 is 108. Okay, so this one compared to 141, so this is success. Okay. Then from here, move up will give you 3 and 4. So 3, 4 will give your function is 155, right? So this is failure. Okay. And then downside. So we have 3, 2. And we have here 71. Success. Okay. Then the next iteration should start at P2, your new base point. Is 3, 2, okay, where FB2 is 71. Okay, same process, right? But the successness and the failure of each iteration here, for each evaluation here, need to consider the constraint. Not just the value of, not just comparing the value of 141 only. So means that for each iteration, what you need to check here is the function 141. So if the function is less than 141, just like in our previous Hooke and Jeeves, it is considered success. Okay, but for this one, it will be considered as success only if it is less than the testing value here and also fulfill the constraint. So here, let's check 5 and 3, right? So 5 and 3, 5 is greater than 0, 3 is greater than 0, and 5 plus 3 is 8 greater than 4. But here, greater than the testing value. That's why it is failure. Okay, and for this one, 108, of course, it is less than 141, and then you need to check 3 is greater than 0, 3 is greater than 0, and x1 plus x2, 3 plus 3 is 6, greater than equals to 4. Then it is success. Okay, understand or not? You have to check one by one that. And then this one, 155, of course, it is failure. And then you check, even though 3 is greater than 0, 4 greater than 0, and 3 plus 4 is 7 greater than 4, it is considered as failure because the value is greater than the testing function here. Okay, and then for this one, 71, of course, it is success, but you have to check 3 greater than 0, 2 greater than 0, and 3 plus 2 is 5 greater than equals to 4. So this is considered success. So the most successful point will be here. Is that clear? Okay, you have to check one by one the point, the objective function, the function value, and the constraint for each constraint. So it must fulfill all constraints, and we have to make sure that it minimizes the objective function. Okay, so if we start with 141, so make sure that it is less than 141. Okay, while fulfilling all the constraints. Okay, now let's proceed. So from here, we have our B2. Then what is your P1? So your P1 should be what? P1 equals to B1 to B2 minus P1. So what is your P1 here? Okay, anyone? What is your P1 there? Okay, 2, 1. All right, thank you. Okay, so now you got your P1, which is 2, 1. So you have to check whether that P1 is fulfill the problem or not. So what is FP1? What is FP1? 25. Okay, of course, it is less than the objective value here, 71. But does it fulfill the constraint? 2 greater than 0. Okay, here. So x1 is 2 greater than 0. x2 is 1 greater than 0. x1 plus x2 must be greater than or equals to 4. So 2 plus 1 is 3, does not greater or equals to 4. Okay, means that Okay, the objective function will be given such a high value if the constraints are not fulfilled. So even though your FP1 is 25 here, okay, then even though FP1 is 25 here, but this point is not fulfill one constraint of x1 plus x2 greater or equals to 4. So we have to give such a high value of FP1 here, such as 10 to the power of 30. Okay, clear or not? So now instead of 25, your FP1 is 10 to the power of 30. So your next evaluation should be compared with this value. Is that clear? Okay, so next evaluation, we explore from P1 and FP1 equals to 10 to the power of 30. So our next evaluation should start at what? What is our next point? So you have to move. Okay, start of 2, 1. So start to move to the right. So you should have 3, 1. So your next evaluation is at 3, 1. So check whether this 3, 1 fulfill or not the constraint and what is the objective function there. So fulfill the constraint, right? 3 greater than 0, 1 greater than 0, and 3 plus 1 greater or equals to 4, and your function is 44. Then compare with this, and it is less than the objective function, so this considered as success. All right. So no need to the left, then go from here, go 3, 2. Okay, so what is 3, 2 here? Fulfill the constraint. And what is the objective value here? 71. Okay. So consider as fail, right? Because it is greater than this 44. And then go downside here, we have 3, 0. So 3, 0, x1 greater than equals to 0, x2 greater than equals to 0, and 3 plus 0 is 3, not greater or equals to 4. So this is not fulfill the constraint, then we just put the value here as 10 to the power of 30. Of course, it is a failure. Okay, is that clear now? Anyone has question? Okay, all clear? So this is how the modified Hooke and Jeeves. Why the value is 10 to the power of 30, how we get it. So that one is just the assumption. So we are going to substitute such a high value for the objective function. Okay, so let's standardize as 10 to the power of 30. All right. So this value is anonymous actually, but for the standardization purpose, we use 10 to the power of 30 here. Okay. All right. So this is the process of modified Hooke and Jeeves. As you can see, it is quite identical with the previous Hooke and Jeeves that we have discussed. But for this case, for this modified case, what we need to consider is you have to take a look at the constraint, check for each testing point, is it fulfilled or not? Okay, check the objective function. If it is not fulfilled, then consider it as a failure, or you can just substitute to the, sorry, not all, and you have to substitute to high value such, for this case, 10 to the power of 30. Okay, clear or not? So let's just proceed. What is your new base point? So your next point should be B3, right? Okay, so your B3 equals to 31 and FB3 is 44. And you can find your P2. What is your P2? Okay, so P2 is 30, where here 30 is not fulfill the third constraint, then we just can decide FP2 equals to 10 to the power of 30. So again, evaluate from evaluation number 9. So we explore it from P2. All right, is that clear? Okay, try to proceed with the calculation up until you reach the H here less than the epsilon. Okay, if you have question, you can ask. After this, you can take a look at least up until evaluation, at least up until H equals to 0.003. So we are going to have more than 30 evaluations. Sorry. You get what I mean or not? Okay, so for this example, okay, again, for this example, actually, the minimum point occurred here, 44, for x1 equals to 3, x2 equals to 1, because this is just the same example that we did previously by using Kantaka method here. Okay, this is the same example, and by Kantaka method, we have x1 and x2, and f equals to 44. So for this modified Hooke and Jeeves, of course, it will have the same minimum point. So that's why it is all failures for every evaluation after this point. So what we are doing just now is only to see the process of decreasing the step lines, okay, and then changing of base point and pattern move point. Okay, so don't worry if you have all failure objective, we'll leave there. Okay, because that is only the process. But you have to know that for this modified Hooke and Jeeves, you have to consider the constraint. And if the constraint does not fulfill, you just substitute to the very high value of 10 to the power of 30 there. That's the only difference between the Hooke and Jeeves and modified Hooke and Jeeves. And the rest are similar. Okay, is that clear? So until you reach the value of epsilon, for this example, you will face all failure objective values and you are going to turn back to these points as your minimum point, the minimum value, and the minimum point is 31. Okay? So you can try to have the rest of the evaluation. Okay, why don't you try another example? Okay, try this example. Okay, so I think all of you still doing this. All right, so please proceed with this, and your minimum value should be 88, all right, with x1 and x2 equals to 31. Okay, so for this process of calculation, even though you have this minimum point at evaluation 5 or 6 and so on, but you have to proceed your calculation only up to h equals to 0.5. So even though you occur your objective value of 88 here at evaluation 5 or 6 or 7, and please proceed with the exploration, move until you reach the value of step length equals to 0.5. Means that your stopping criteria is fulfilled. Okay, so that is how we do it. Because for the simple example, of course, we are going to occur our minimum value at the early evaluation, so on. Okay, so the process here can be used for complicated example, such that you will have your minimum value at a bigger number of evaluation. Okay, is that clear, all of you? Anyone has question? Okay, good. So from 1 to 10, where are you for this method? Okay, good. All right, so we have done with the constraint optimization. We have here Lagrange, Tucker, and also this modified Hooke and Jeeves. So we are going to use these three methods for your final exam purpose. There's still one method which is penalty function. But that one I'm not going to ask for your final, but I will give you the notes in the recording later on by using sorry. Okay, the penalty function is not included in your final exam, but I'm just going to give you the notes for your knowledge purpose. Okay.